Hi, I'm Amelie Bouchat and I'm a new MEOPAR postdoctoral fellow working at McGill University. Today I'd like to introduce you to a new project that we're just starting with colleagues from McGill, FNAF, and NRC, which aims at developing seasonal predictions of ice conditions in the St. Lawrence Seaway using artificial intelligence. The St. Lawrence Seaway that you see here in the green circle is a combination of 15 locks that allow ships to navigate between the Great Lakes and Montreal, and it plays a major economical role in North America with over 200 million tons of cargo transiting each year. The Seaway typically opens for navigation in late March when the river ice starts melting, and it closes in late December with the onset of the winter ice cover. However, at the moment, the closing and opening dates are approximated each year by the Shipping Federation of Canada based only on a 1-month temperature forecast that's submitted by Environment and Climate Change Canada, which actually contains no ice information. And this is because there's currently a lack of ice condition forecasts for the Seaway region. There are, in fact, high-resolution coupled ice-ocean models that are set up for the Great Lakes system and for the Gulf and estuary of the St. Lawrence River, but there are no ice forecasting system in place for the remaining section between Quebec City and Lake Ontario. And this lack of prediction represents actually a considerable challenge for the planning of safe operations in the shoulder seasons, since the presence of even the thinnest ice can be fatal for ships that were not designed to navigate in icy waters. And in addition, being able to predict ice conditions on a weekly time frame could help to monitor potential ice jams area in the spring breakup period, and therefore to better plan for ice breaking operations in this region. So our goal is to develop a freeze-up forecast model for the St. Lawrence Seaway, and specifically we will explore the use of a machine learning infrastructure to do so. Now, the idea of this type of model is that compared to traditional models in which you feed observed data or forcing, and then you specify the set of rules for how the model should act with this data to return you answers or numerical values of a given variables. Here, with the machine learning model, you instead feed both the forcing and the expected values that you want your model to return, and then you let the model find what is the set of optimal rules that can be applied to future observations to make new predictions. And the application of machine learning for ice prediction is not new in the community, but it's still in an experimental phase. And for us, the advantage of this type of model is that they should be much less expensive to develop and run at the very local scale, since, for example, we do not need to implement a very fine grid to capture all the details that are happening in the Seaway. But instead, we just let the model discover correlations in the data that will be given to it, and then it will use only that necessary information to make its predictions. In our case, we expect that the ice and water conditions in Montreal in the Seaway will be highly correlated with conditions near Lake Ontario and the Great Lakes, given that the flow of the river establishes a direct connection between both locations. So we're currently in the first phase of this project, which is the data collection phase, and the goal is to develop a proof of concept model that should be ready for application to predicting the freeze-up conditions in the Seaway by next year. And for now, in the data collection phase, our goal is really to get our hands on time series of predictor variables such as air or water temperature and ice conditions at different stations along the river. And we want those time series to be as long as possible, even if they are of lower quality. And this is because the longer time series that we have, then the better it will be for training the model to discover the correlations to exploit in the dataset. And we're actually compiling this dataset from a number of different sources. And our goal is to make this centralized dataset accessible for the community for future studies related to the St. Lawrence River. And in addition to this database, we plan to publish a web-based application that will be publicly available with the forecast model that can be used by private and governmental stakeholders to better manage ice risk and resource planning for navigation in the St. Lawrence River. And also, in addition to navigational needs, we hope that this tool can provide monitoring of river ice jams and floods in the spring in complement to local observations, of course. Now, if the proof of concept that we develop now is successful for the St. Lawrence River, there will also be the possibility to extend this framework to other regions, such as the estuary and Gulf of the river, but also maybe in the Canadian Arctic archipelago. And I would just like to end this presentation with asking if any of you have available water and ice data sets for the St. Lawrence River or know information about them, to please contact us because we would be interested in compiling that for a project. Thanks a lot for listening.